5 years before this photograph was taken, this entire piece of land was open ocean, and the men standing on it right now are about to bury 211 meters of concrete and steel into ground that didn't exist when they were born. And if you think that sounds insane, wait until you hear what's underneath it, because 38 square kilometers of seabed got vacuumed off the bottom of the Persian Gulf and stacked into dry land, and on top of that impossible ground, engineers were handed a single coin, a coin with 2 crossed swords stamped into the metal, and told to build AOGK Skyscraper that looked exactly like it, and every single person in that room knew the ground beneath. Their boots could barely hold a parking lot, let alone a pair of leaning, curving 200-meter towers rising out of nothing. And this is the story of how they did it anyway, 4 years. Over 2,000 piles driven into rock nobody could see, 8 concrete spines climbing at different speeds, and one decision so strange that if you got it wrong, the entire building would have failed under its own weight before a single guest ever checked in. So stay with me, because by the end of this, you're going to understand why engineers around the world still can't quite believe this thing is standing. Let's start where every impossible building starts, underground, in the dark, with soil nobody trusted, because before a single pile went into the earth, engineers had to know exactly what they were dealing with 20 meters down, and what they found should have ended the project on the spot. Loose, reclaimed sand sitting on top of soft marine clay, ground so weak the blow count readings barely registered on the instruments. This wasn't soil that could carry a tower, this was soil that could barely carry itself, and somewhere far beneath that soft, sandy nightmare sat the one thing that could save them: solid rock. But it was buried so deep that reaching it meant drilling through everything above it first. So here's what they decided to do, and it's the kind of decision that either makes you a genius or ends your career. They designed 2,060 7-board piles, each one a meter wide, each one driven 35 meters down through weak sand and soft clay, until it hit rock hard enough to trust. Picture a barrel wide enough to climb into, drilled deeper than a 10-story building is tall, and here's the part almost nobody outside construction ever hears about. The second you drill a hole like that in reclaimed ground near the sea, the walls start collapsing in on themselves, so workers pumped in a thick engineered fluid called bentonite slurry, and that slurry becomes the only thing holding the hole open long enough to build inside it. Then 35 meters of steel reinforcement gets lowered into that hole, a cage taller than most buildings, lowered with centimeters of clearance on every side. Miss your mark, and the whole pile is compromised before concrete ever touches it, and once that cage is set, concrete gets pumped from the bottom of the hole upward through a pipe, because if you pour it from the top, the mixture separates and turns into a structural time bomb buried where nobody will ever see it again. And every single one of those 2,067 piles was tested with sound waves after it cured, because if that wave breaks anywhere along its path, that pile is rejected and re-drilled. No exceptions, not on a building. This tall, added up, and you get 50,000 meters of piling driven into the earth beneath a 48,000 square meter plot, more buried steel and concrete than most bridges use in their entire lifespan. And that's before the tower even breaks ground. But here's the twist. Nobody saw coming once those piles were locked into rock. Engineers still had to dig 10 meters straight down into land that used to be underwater, which means they were now holding back the Persian Gulf itself with nothing but concrete. And this is where one mistake could have flooded the entire site. They built a wall of interlocking, secant piles, hard concrete columns alternating with softer ones cut directly through each other like interlocking teeth. And in the spots carrying the heaviest load, they added a diaphragm wall, 1.5 meters, thick, reinforced perimeter armor against the sea. And it almost wasn't enough, because during excavation, water started finding its way through. One small leak. And on a site like this, one small leak doesn't stay small. Water pressure from the Gulf multiplies every crack until the whole excavation face is at risk. So crews injected expanding grout straight into the leak, foam that swells inside the crack and seals it shut against the water pressure trying to force its way back in, and for over 12 months straight, dewatering pumps ran around the clock without stopping, draining a hole bigger than 20 Olympic swimming pools while engineers measured the walls every single day. Because if that wall shifted more than 20 millimeters, the entire excavation would have been shut down on the spot. And think about that for a second. 10 meters below the surface, standing on land that was ocean floor 5 years earlier, with pumps fighting the sea nonstop for an entire year just to keep the hole dry enough to build in. And once it finally was dry, the real construction could begin. Pile caps to spread the load from the columns above down into E, the piles below, ground beams tying every single cap together so the piles couldn't splay apart under pressure, and in 45-degree heat, freshly poured concrete. Starts cracking within hours if it isn't protected immediately. So every pour became a race against the desert sun itself. 2 full basement levels went in below ground, parking, mechanical rooms, and a waterproofing membrane that stands as the only barrier between this building and the Gulf's groundwater forever, Get that wrong, and the basement floods permanently with no way to undo it. A 400-millimeter slab was poured to resist the upward pressure of groundwater trying to push back in from below, reinforced with 2 complete mats of steel bound together by hundreds of connecting links, poured in a single 16-hour continuous pour. Because if that concrete ever stopped and restarted mid-pour, it creates what's called a cold joint, a hidden structural weakness baked permanently into the foundation. And then, right when the basement was finally sealed, engineers discovered a problem in the design that forced them to rethink everything. One section of slab was going to carry more load per square meter than almost anywhere else in the entire structure. So they thickened it by 400 additional millimeters and doubled the density of steel running through it. Problem solved. But only because somebody caught it in time. And all of this, every pile, every wall, every basement slab, exists purely so that 36 floors of hotel could eventually rise on top of it without anyone upstairs ever knowing how close the whole thing came to going wrong beneath their feet. Now, here's where the story gets strange. Because the ground floor of this podium stands 6 meters tall, nearly double a normal story, built to carry a ballroom above it, supported by beams 4.8 meters deep, taller than the ceiling of most apartments, reinforced with 40-millimeter steel bars, bundled in pairs because a single bar wasn't strong enough to do the job alone. And this is where engineers ran into a problem you'd never guess existed. Concrete that strong generates so much internal heat, while curing that it can crack itself apart from the inside. And during one of these massive pours, the concrete core temperature hit 71 degrees, just 1 degree over the safe limit, 1 degree away from a beam cracking invisibly from within before it ever supported a single floor above it. So crews pumped chilled water through pipes laid directly across the beam's surface, and slowly, carefully, the temperature dropped back under 70, and the beam survived. And above that beam sits a void that will one day become a hall 22 meters tall, meaning every column surrounding it had to be placed with 0 margin for error, because there was no room to hide a mistake in open space that large. And once that podium finally locked into place, engineers pulled out a forest of steel props holding the entire load in place, one at a time, watching the beams flex under real weight for the very first time. And when the podium held, that's when the towers were finally cleared to climb. And this is where the 2 swords started to become real. 8 concrete cores. The spine of the entire structure, everything else, every floor, every wall, every pipe, hangs off these 8 cores like ribs off a spine. 4 of them climbed using a self-jacking system that lifts an entire enclosed platform upward using hydraulic rams, pushing off the wall itself, workers inside placing steel with no crane pick and no open exposure to a 200-meter drop. And the other 4 climbed the older way, crane-lifted formwork, repositioned by hand with every single floor. Slower, but exact. And here's the detail that should stop you cold, because this tower doesn't just go up, it leans. The architecture curves outward as it rises to form the blade of the sword, which means the formwork angle had to change on literally every single floor. Engineers built wedge-shaped panels specifically to compensate for a lean that gets more pronounced the higher you go. And every single core pour followed a strict rule. Pour too fast and the wet concrete pressure blows the formwork apart from the inside. So, as the walls climbed higher, crews slowed the pour rate in half, doubling the time. Every pour took just to keep the walls from bursting under their own weight, and by floor 18, you could finally see it happening in real concrete. The lean the architects had only ever drawn on paper was now hanging 200 meters over the Persian Gulf, and every single pour required a fresh survey of the wall's exact position before crews were even allowed to begin, because the 8 cores weren't just moving upward, they were moving at 8 different speeds simultaneously. 4 automatic systems, 4 crane-lifted, each one a slightly different height, controlled chaos climbing skyward all at once. And because Qatar's daytime heat above 45 degrees ruins the curing process, crews shifted the heaviest pours to nighttime when the concrete could set properly instead of racing the sun. And by floor 30, with only 6 floors of core left to go, the shape was finally unmistakable. 2 swords rising against the sky, exactly like the coin that started this whole obsession. But while the cores climbed above, an entirely separate battle was happening below, because the floor slabs had to chase the rising cores from underneath. 2 construction fronts racing each other up the same building. And here's the detail that nearly wrecked the entire schedule. Every single floor of this tower has a different shape. 36 unique floor plans, meaning 10,000 square meters of custom formwork tables had to be manufactured individually, 1 set per floor, no 2 identical anywhere in the building. And a lifting system was engineered specifically to raise these massive tables 2 floors at a time without ever needing a crane, cutting the entire slab schedule dramatically, and every single balcony cantilevers further outward than the balcony directly beneath it, because the curve of the tower demands it floor after floor after floor. And every duct, every cable, every pipe running through these slabs had been designed 2 years before the concrete ever touched them, positioned with a precision that left absolutely no room for improvisation on site. 90 cubic meters of concrete pumped every single hour. The weight of a double-decker bus poured into these floors roughly every 10 minutes. And floor flatness mattered more than almost anything else, because a warped floor means doors that never close right and partitions that never quite fit. So drones equipped with thermal cameras scanned every single freshly poured slab, hunting for hidden hotspots floor after floor after floor. And in the ballroom, where the floor had to span an enormous distance without a single column interrupting it, engineers threaded steel tendons directly through the wet concrete and pulled them tight after the pour. 19 tons of compression locked permanently into a slab that would otherwise sag under its own weight the moment the formwork came away. And floor by floor, the crescent shape of the tower extended outward exactly as designed. Every single curved steel beam individually cut by computer-controlled machinery in a factory hundreds of kilometers away just to match the building information model down to the millimeter, and somewhere 50 meters. Above the ground, iron workers caught a 12-ton steel beam swinging in open air with nothing but muscle, timing, and a steel spud bar. No room for hesitation, no second attempt, and once that beam locked into the concrete column beside it, shear studs welded the steel and concrete together into a single working structural system, doubling its strength in the process. And here's something almost nobody expects. Construction actually got faster the higher the towers climbed, because by that point, every single system on site had been refined through repetition into pure muscle memory. And finally, floor 36. The very last lift of concrete on the entire structural spine of the building poured 18 hours straight, overnight, in the dark. 211 meters above a body of water that used to be nothing but open gulf. And when the final survey came back, every single one of those 8 cores was found to be within 8 millimeters of its exact theoretical position across the entire 211 meter height of the building, a level of precision that most engineers will tell you shouldn't even be possible at that scale. But the structure was only half the story, because now the building needed a skin, and this is where things get almost unbelievable. None of the 5,000 facade panels wrapped around this tower are the same size. Every single one was engineered and manufactured individually to match one specific position on a curved, leaning surface, glass bent at 650 degrees Celsius to hold the exact curve of its one and only location on the building, reinforced with a specialized laminate 5 times stronger than standard safety glass. And even the aluminum framing holding those panels was individually curved by computer-controlled machines to match the unique arc of its floor, not a single straight profile anywhere on the entire tower. And a single logistical mistake, one panel delivered to the wrong location, cost the project 4 full hours and an entire crane shift on a build, racing against a hard World Cup deadline. So every panel was GPS tagged straight from the factory, meaning the crane operator could see the exact floor and position of every single piece before it was ever lifted into the sky, each one clicking into a bracket already cast permanently into the slab edge below it, engineered to allow for thermal expansion. And seismic movement without ever cracking, arriving fully assembled so crews could simply click, seal, and move upward, no on-site glazing required. And every single facade section, all 36 floors of it, had to pass a water test before it was ever accepted, because one leaking joint anywhere across that entire skin and the whole building's integrity comes into question. And then, one day, the protective netting finally dropped away, and for the very first time, the entire building stood completely visible with nothing obstructing it, and it was breathtaking. But the tower still wasn't finished, because inside an entirely invisible war was underway. 4 massive centrifugal chillers combined to deliver 8,000 tons of cooling capacity, pressure tested at 16 bars for a full hour straight. Because if that pressure dropped even slightly, it meant a hidden leak was hiding somewhere inside a shaft wall that nobody could easily reach once the building was finished. Every duct route through the entire tower had been computer optimized specifically to minimize turns, because every single bend bleeds air pressure. The system can never get back. Sensors embedded in the ballroom ceiling read carbon dioxide levels in real time, automatically increasing ventilation the moment a room fills with people. And then came the moment every single engineer on this project had been waiting years for, 3,000 volts flowing into the building for the very first time. And somewhere on that site, every single person old enough to understand what they were watching held their breath. And after that came 36 floors of sprinkler testing, every head, every alarm, every single one, because a fire suppression system doesn't get a second chance if it fails when it actually matters. And finally, the very last commissioning certificate was signed, confirming every single system inside a 211-meter hotel tower had been tested, verified, and cleared. From soil nobody trusted 20 meters underground, through 50,000 meters of piling driven into rock, through 8 cores, climbing at 8 different speeds, through 5,000 facade panels that no 2 of were ever the same. into a finished building that, 5 years earlier, would have been standing in open ocean. And that's the story hiding behind every photograph you've ever seen of these two towers. Because from the outside, all anyone ever sees is a beautiful pair of swords catching the sunset over Doha. But underneath that image is 4 years of engineers making decisions where a single miscalculation could have meant total failure. And they made every single one of those decisions correctly. And if this kind of engineering story fascinates you the way it fascinates us, hit subscribe, because we're already deep into researching the next impossible build, and you will not want to miss where we're going next.